Hi, this is the next video for chapter 14 of Exponentials and Logs. In the last video, I showed you how to solve exponential equations using logs, and we looked at some easy-ish equations that were written in the form base power equals answer. And I did show you two methods, although I predominantly used one method. One method was to write it in log form. The other method was taking logs. Now in this particular question, and for the next three questions after it, we are not going to be able to write it in log form because it's not in this form here. There is an extra index. So we cannot just write this in log form. Our only option for these questions is to take logs, which means that we are going to apply the function log to base 10 to both sides. So I'm doing it to both sides because that's what we do when we solve equations. Whatever we do to both sides of the equation. So I'm going to apply the function log to base 10 to both sides. So log to base 10, so I'm just not writing the 10, that's why we tend to use base 10. Log of 5 to the 2x equals log of 2 to the x plus 1. This is still true because I've written log to base 10 in front. Okay, we could use any log, any base, but we tend to use 10 just because we don't have to keep writing it every time. It's the main reason. The reason why we take logs is because we can now, because we've done that, we can now use law 3 of logs to bring those indices down to the front. So that is the same as 2x log 5, and that's the same as x plus 1 lots of log 2. Okay, so the x is no longer an index, which is going to help us solve now. Now this log 5 is just a number, and this log 2 is just a number. I'm not going to stick it in my calculator and get an answer because it'll be a decimal, so we'll lose accuracy at this stage. So we're just going to leave it in logs. What we can do is expand some of this out. So we've got 2 times x times log 5. Now that's a number and that's a number. So actually, we've got 2 log 5 lots of x there. And then because this is just a number, we've got a number lots of the bracket. So we can expand the bracket and say we've got log 2 lots of x there plus log 2. Now if you notice I've written the logs after the x. That's just to avoid ambiguity, because if I'd have written it as log 2 lots of x there, we don't know if that's 2 lots of x or if it's log of 2x. So we tend to just write it after the x, just so that it's clear. Right, we've got 2 terms that have got an x in. So I'm just going to take x log 2 to the other side. So I'm just gathering up the like terms. And now, just to make x appear once, I'm going to factorize. So 2x lots of 2 log 5 minus log 2 equals log 2. And then to get x on its own, I'm going to divide. So x equals log 2 over 2 log 5 minus log 2. Okay, now at this point, what you're not going to do is cross them out. You cannot do that because this is not written as a product. 2 things you can do and are allowed to do. 1, you could use the laws of logs to simplify this, to write it as a single log. So the top bit will be log 2. This is log of 5 squared if you bring that up. So it's log 25. Log 25, take log 2, that uses log 2, the log of 12.5. Okay, so you could sort of simplify it, but I wouldn't tend to bother. They're quite happy, or they will expect you to probably give this as a decimal. So you can just stick this in your calculator. Log of 2 divided by brackets, all of that, which is exactly what I did to get 0.274 to 3 sig figs. And leave your answer in as 3 sig figs unless you are told otherwise. Right, let's have a look at another one. Okay, so again, we've got indices on both sides. So I'm going to take logs, bring the index down to the front, bring the index down to the front, expand the brackets. So we've got x lots of log 3 plus 2 log 3 equals 2x log 4, or x lots of 2 log 4 minus log 4. Now there's 2 terms with an x in and 2 without. So I'm going to just rearrange that. If I take the x 2 log 4 to move that over there, and if I take the 2 log 3 from the left-hand side and move it over to the right. So I've moved that over there, and I've moved that over there. Now I can factorise. And then we just need x now to be on its own. So I'm going to divide by all of that lot. So it's over log 3 minus 2 log 4. And again, you can just stick that in your calculator and you will get 2.14 to 3 sig figs. Okay, the next two are slightly harder. 2 to the 2x plus 1 equals 7 to the x minus 3 times 2 to the x. So we've got this extra little bit here. Now, if you notice, this is the same base as this. So we don't have to do anything too difficult. We can get rid of this by dividing by 2 to the x. If I divide this side by 2 to the x, that will just cancel that 2 to the x. If I divide this by 2 to the x, well, if I use the laws of indices, 2 to the 2x plus 1 divided by 2 to the x, we're taking the indices, aren't we? So we'll be left with 2 to the x plus 1. So 2 to the 1x plus 1 equals 7 to the x minus 3. So if you get a question like this, look to see if you've got the same base. Now it's just the same, so we can go from here, take logs, then we can bring the powers down. Now we can expand. So x log 7 minus 3 log 7. And then we just need to shuffle everything over, rearrange. X log 2 minus x log 7 equals minus 3 log 7 minus log 2. 2 more steps, factorise. to get x to appear once, and then divide to get x to appear on its own. And then if you stick all of that lot into your calculator, you'll get an answer of 5.21. Okay, now last one I'm going to show you. Similar to the previous one, where we've got this extra thing, but the base is different. The base is different, the base is different. Okay, so what we can't do is use laws of indices to combine any of these. We can't do anything daft and say that's 6, for example. Doesn't work like that. So in this instance, all we can do is take logs, and I'm going to take logs of all of that. So I'm treating that as one term. I can't stick a log in here and stick a log in here. That's breaking the law. Okay, but what I can do now, because I have a log of a product, I can use law 1 to say that's log of 3 to the x plus log of 2 to the x minus 1. So I've used the first law of logs to split that product into an addition of 2 separate logs. And after that, it's just going from there, following the same routine. So I'm bringing all those indices down. It's just a little bit more long-winded, that's all. Expand. We've got x log 2 minus log 2 equals x log 5 plus 2 log 2. 5, sorry. And now we just need to gather everything up. X log 3 plus x log 2 take x log 5 equals, so I've just taken that over the other side, 2 log 5 plus log 2. Factorize log 3 plus log 2 minus log 5 equals 2 log 5 plus log 2, and then just divide. Or you could simplify first using the laws if you want to. Be less to write down, I suppose. Plus log 2 take log 5. Okay, so either simplify or just stick it into your calculator. Either way, you'll get to 21.5 to 366. Okay, now this is the end of this video. In the next video, I will look at some that have got disguised quadratics.